Thanks for having us. I'm just going to give you a very quick overview of CART, and then I'll pass it to Alex for the real presentation. So for those I see some familiar faces in the room. That's great, our past partners. For those of you who don't know us, Center for Analytics and AI Engineering is the hub for collaborations around AI and ML at U of T's Faculty of Engineering. We partner with private sector, government, and nonprofits on training. So we offer machine learning boot camps, on recruitment, be it graduates or interns, and also on conducting applied AI projects. So please feel free to reach out to any of us after the talk, and we'd be happy to talk about ways to partner with us. Without further ado, I'll just pass it to Alex.
Okay, hi everyone. My name is Alex Olson. As I was introduced, I'm a senior research associate at CART, and today I'm here to give a little bit of an introduction about large language models like GPT. I'm going to try to explain how they're built in a way that is accessible to everyone, so hopefully you'll leave here with a little bit of a better understanding of how these models are created. So let's start off by talking about what exactly a language model is. At its core, a language model is a probability distribution over a set of words. And we use that to estimate the likelihood of some sequence of words occurring. So, for example, on the right here, we can estimate the likelihood of seeing the phrase "the dog and the cat" versus the likelihood of seeing the phrase "the dog and the ostrich." Now, in order to use a language model to generate text, we can compute the likelihood of any given word being the next word in that sequence. And then we can just select the word that maximizes that likelihood. In practice, this is something that we can do by looking at as much text as we can. By doing that, we can build a better and better estimate of the likelihood of various phrases and sentences. A very simple approach is, for some given sentence, we can look up the number of times that sequence occurs in a reference data set. Of course, this approach isn't very sophisticated, and it quickly runs into the issue of requiring more and more data the longer that the sequence we want to evaluate is. So there's many more sophisticated approaches, and in the last few decades, those have largely revolved around neural networks. And what do we mean when we talk about a large language model? It's exactly what it sounds like. The latest models that we have are capable of learning from much, much more data than early models were. I have a graph on the right here that shows the size of neural network-based language models over the last 40 years. The y-axis here is logarithmic, so that long straight line that you see is actually an exponential increase in the size of these models. But as you can see, in the last 5 years or so, there's been an explosion in the size of these models. A large part of the reason for that explosion is due to the introduction of attention in neural networks, and I'm not going to get into a lot of the specifics of how attention works here, but the takeaway is that this has made it possible to learn from much, much larger sequences of text than were possible before. And the other side of this is that in recent years, companies have been willing to invest more and more money in training these models. OpenAI hasn't made public exactly how much it costs for them to train their models, but it's been estimated that training GPT-3 could have cost them anywhere in the range of $400,000 to $4 million. So the developments in this area in the last few years are both thanks to some technological advances, but also just an increase in the amount of money and resources being spent on training. And what actually is GPT in particular? So in 2018, OpenAI released a paper describing a new model that they called the Generative Pre-trained Transformer. And I'm going to break down that name. Generative is exactly what it sounds like. This is a model that creates something, in this case, text. And GPT is based on a novel type of neural network called a transformer. I mentioned attention on the last slide, and a transformer is essentially a type of neural network that uses attention. But the real innovation is the pre-trained part in the middle here. I'll get into a little bit more about what that means in a couple of slides, but the bottom line is that the key innovation in GPT is the way that the model is trained rather than the architecture, which is largely based on approaches that were already published. GPT-2 and 3 are almost exactly the same model as that original GPT, but they each they introduce some slight modifications that allow them to be trained with substantially more data. GPT-2 is trained with about 10 times the amount of data as the original GPT, and GPT-3 is trained with about 1,000 times the amount of data. And then GPT-4 is trained on even more data than that. Sorry, yep, yeah. It also contains an optional component that allows the model to recognize the content of images. There's been a few applications of this. It's in early development. They haven't released a lot of specifics about how that works. OpenAI hasn't been the most consistent when it comes to naming their products and tools, but they've largely settled on this nomenclature that GPT-3, 3.5, 4 are the actual models, and Chat GPT is a product that uses those models. So I've said that these models are trained on a huge amount of data, but what's actually included in that? The GPT-3 paper includes a very, very brief overview of the data that's used in training. It's comprised of 5 data sets. Before we go through them, I'm just going to quickly define the terms in this table. So we have the name of the data set, and then we have the quantity of data in tokens. A token is the smallest unit used by the model, and it corresponds typically to a little bit less than a word. The reason it's less than a word is that there can be some situations where a word is broken down, like for compound words or words that are gibberish. And then the term weight in training mix just refers to the fact that OpenAI shows samples from some of these data sets more often than it shows others. So the first and by far the largest data set used in training GPT-3 is Common Crawl. Common Crawl is an organization that maintains a publicly accessible library of billions of web pages that they began collecting 7 years ago. WebText2 is a similar data set, but it only contains web pages that have been shared on Reddit. The concept here is that by only collecting pages that have been actively shared, their data set would hopefully contain higher quality web pages on average. GPT-3 is also trained on 2 data sets comprising books, and this is where things get a little bit more vague. In the GPT-3 paper, OpenAI only refers to these data sets as books 1 and books 2. They don't give much more detail about what those books are or where they come from. Since GPT-3's publication, researchers external to OpenAI have tried to uncover what those 2 data sets are. This is important not just for understanding the behavior of the model, but also for replicating the results that OpenAI presents. Books 1 is highly likely to be a data set called Books Corpus, which describes itself as a collection of freely distributed ebooks. However, there's no official public version of this data set. Instead, there are a handful of different versions floating around, and they're not that easily found. Researchers investigating OpenAI's particular use of this data set found that the most widely used version does contain many books with copyright restrictions that should have prevented their inclusion. And this may not be the version that OpenAI used, but without more information, we can't totally be sure. There's even more mystery surrounding the Books 2 data set. To this day, we don't actually know what this data set is. One hypothesis notes that the size of Books 2 in tokens closely aligns with a data set obtained from an illegal file sharing site for copyrighted works. But without any access to the data, there's no way to be sure what the source actually is. And then finally, bringing us back to something less concerning, GPT is also trained on English Wikipedia. So let's talk a little bit about how the models used in Chat GPT were trained and why that's so innovative. I'm going to break this down into 3 parts. An important thing to understand here is that when the model for Chat GPT is being trained, they're actually starting with an already fully trained GPT model. So before we even begin here, they've already created a model that is capable of the general problem of just generating text. This model has already seen those billions of pages of text from the internet and books, etc. The challenge here is to take that general model and turn it into something that is very good at the conversational prompt response style. So OpenAI starts with a set of prompts. For example, here we have explain reinforcement learning to a 6-year-old. They then have a set of human annotators who write out full answers to that question. They take the pre-trained GPT model and they teach it to relate these prompts to these answers. In the second step, human annotators write more answers to the same questions, so that we have a handful of answers for every single question. And somebody else ranks the quality of those answers from best to worst. OpenAI trains a completely separate model, which just learns to rate the quality of an answer based on the question. Again, this model is actually distinct from GPT. All it's doing is taking in a question and response and giving a score indicating how good that response is. This is the reward model. It rewards GPT for good answers. Finally, we take our model, which has been shown some of these question-answer pairs, and we ask it to create completely new answers to some of the questions in the dataset. The reward model rates the quality of those answers, and this continues in a loop where GPT receives a question, writes an answer, and gets a score of how good that answer is. This allows GPT to keep learning, even though OpenAI doesn't have human-written answers to all of these questions. So in this way, OpenAI can take a dataset with just some human annotation and get a lot more mileage out of it for training their model. At the end of this process, we have a model that was initially trained on this general task of creating data, but it then is what we call fine-tuned on the task of responding in this question and answer style. This approach, as well as some approaches that are quite similar to it, represent one of the largest contributions that OpenAI has made to the field of large language models. But this approach is not without issues. In this final step, we no longer have a human involved in the process. We have one model that's being trained by another. That means that the quality of the Chat GPT model that's produced is highly, highly dependent on the quality of the model that's ranking it. Another way to think about this is that Chat GPT's goal when writing an answer is to produce something that it thinks will get a good score from the reward model. And that's supposed to correspond to a good answer, but it's not exactly the same thing. So even though the GPT model that we start with in this process has seen billions of pages of text, the fine-tuning stage is based on a much smaller sample of these question-answer pairs. This means that each question and answer has a vastly outsized influence on the performance and behavior of the model. In practice, the first paper where OpenAI proposed this approach describes using a dataset that's drawn from Reddit. So there are significant biases stemming from the people who are producing the questions and answers that are used to train the model. In addition, that paper records the demographics of the people who are ranking the responses in the stage that was used to train the reward model. The majority of those people were young white American men. Obviously, when you're ranking responses to a question, there's no objective best answer. It's down to the subjective opinion of these people. And so this is a stage where the biases of those people can come in and affect the model. In essence, the reward model is learning what its annotators think is important. There's an average rating that's derived from annotators' feedback, and that's used to generate a subjective sense of quality. To give OpenAI some credit, they have spoken quite openly about a lot of these issues, and there are numerous ways that are being researched right now to try to address or alleviate some of these problems. But at the moment, many of the models that we see and are able to use online do suffer from these issues. Let's go. I'm going to skip a couple of slides for time. Let's talk about some more of these caveats. When the training process is happening, OpenAI tries to train the model to decline to answer certain types of prompts. They probably do this by inserting question-answer pairs where the question is offensive or political or in other ways inappropriate, and the response is just a refusal to answer that question. So on the right here, we see someone has asked ChatGPT to write a scientific article about the benefits of eating glass, and ChatGPT has responded by saying that's not possible. Glass is not beneficial to eat, and in fact, it's dangerous. But in practice, these safeguards are easy to circumvent. The user just replied and said, well, pretend that you did want to convince people. And the model went on to give them the answer they were originally looking for. I've cut it off here, but it wrote a long response detailing the benefits of eating glass. Because there's a disconnect between the vast amount of data that GPT-3 is trained on and then the much smaller amount of data that ChatGPT is fine-tuned on, the model's not always completely aware of its own abilities or limitations. In this example, a Danish user asked ChatGPT to speak to it in Danish. ChatGPT responded and said, I'm sorry, OpenAI only designed me to speak in English. I can't speak in Danish, but I'm happy to talk to you in another way. But the problem is that this response was actually written in Danish. The user was able to then continue that conversation on, where they were arguing with ChatGPT about what languages it could speak, but the entire conversation was in Danish. So this is the disconnect between the fine-tuning step, where the model is taught that it's capable of certain things and that it should respond in a certain way, and the original training step, where it's just given this vast, unsupervised set of documents, which probably or obviously included some Danish. ChatGPT also has a tendency to invent facts that can sound real if you're not familiar with the area being discussed. For example, on the right here, a user asked ChatGPT what the world record is for crossing the English Channel on foot. Rather than correctly responding that that's impossible, the model instead responded with a detailed answer, including the name of the person who did this and when they did it. This is clearly a silly example, but you can imagine that for a more subtle question, it can be hard to distinguish whether the model is telling the truth or not. It sounds like it knows what it's talking about. This phenomenon is referred to as hallucination, and at least when ChatGPT came out, it was estimated that ChatGPT was making up convincing facts around 15 or 20% of the time. When ChatGPT was released, researchers quickly noticed that the model was very good at answering certain types of exam questions. This made headlines, particularly when GPT passed the bar and other such examples. In response to this, OpenAI tested GPT-4 on a large range of written exams, from high school chemistry to medical qualifying exams. They found that for many of these tests, GPT-4 easily achieved a passing grade. But this isn't the whole story. For one thing, even in situations where GPT might never have seen an exam question before, there's a good chance of a very similar question showing up in its training data. This is still useful in a lot of situations, but it's closer to remembering something that you've learned by rote than it is to reasoning and thinking through an answer. On this note, there were a pair of Princeton researchers who put this to the test by comparing GPT-4's performance on two examples of the same exam. One was administered before GPT-4 was trained and one after. They found that while GPT-4 scored perfectly on the earlier exam, the model didn't get a single answer on the later one. GPT-4 is still useful in a wide range of applications, to be clear. But the point I want you to take away is that we should be wary about headlines claiming that GPT is passing various exams. There's a very big difference between remembering the answer to an exam question and being able to figure it out for yourself. Okay, let's see. I'm going to run out of time soon, so I'm just going to do a few more of my slides. But as we discussed earlier, it's extremely expensive and time-consuming to create a model like GPT-4 from scratch. But luckily, in most cases, we don't need to. Companies like OpenAI offer a service where they'll train a custom version of their model with additional data provided by you. This fine-tuning is done after the main training is complete and allows the model to take advantage of its more general knowledge while adding on specific domain knowledge for the task at hand. This fine-tuning process typically requires some familiarity with programming a neural network, but the actual task of training the model is handled by the service provider, so you don't need to pay for substantial computing resources. To train a model like Chat GPT, data needs to be provided in a question and answer format. This can be created specifically for the purpose of training the model, but you can also take advantage of data that might already be in this format. For example, FAQs and documentation are good examples of data that already are kind of in that style. OpenAI currently offers this fine-tuning service for their GPT-3 models, with GPT-4 in early testing to be released for the same thing. At the most basic level, starting this fine-tuning only requires a single line of code. It's worth noting that while the training cost is actually quite inexpensive, querying a fine-tuned model from OpenAI is about twice as expensive as querying the general GPT-4 model. Another provider that you might be familiar with, I think they're actually here, is Hugging Face. They offer a wide variety of services around developing and training LLMs, which is why they're one of the first companies to provide this type of product. At least one version of their tool doesn't require any programming at all to fine-tune a model. Instead, you can upload data directly to their website and they handle the training. Amazon has announced their own fine-tuning platform called Bedrock. It's currently in limited availability, but it will provide access to fine-tuning for a wide range of models. I think I'm almost out of time, so I'm gonna fast forward to the very end here. I had some examples. I'll talk about what's gonna happen in the long term. So in the short term, things are going to be integrated into existing products. There'll be easy wins where they can be found. But in the long term, it's difficult to know exactly where these models can be, whether these models can address many existing problems by releasing a slightly updated model, a version of existing models, or whether they will require a paradigm shift that's at the same scale as the one that we've just seen. It's likely that we'll see incremental improvements over the coming years, but it's important to remember that language is just one aspect of intelligence, and the next seismic development might come from another area of AI entirely. So to bring everything together, large language models function by successively choosing what they estimate to be the most likely word to follow in a sequence. They're trained from vast quantities of text that are sourced from some legitimate and some potentially dubious data sets. Models like Chat GPT are fine-tuned on a much smaller set of question and answer pairs, which means they're susceptible to a range of biases introduced by human annotators. GPT models have a tendency to hallucinate false information, which can be convincing to outside observers. They also struggle with things like creativity, handling context that's far outside of the immediate question, and following rules for an extended session. But in spite of all of this, there's huge potential for benefit from LLMs, as long as we're thoughtful about the tasks that we try to use them for and cautious about their output. Okay, thank you very much. I don't think we really have time. It's all right. I'm happy to talk to people afterwards if they have questions for me directly, but I think that just so the next person can get set up, we'll not do a broader question and answer. Thanks.